Hello, you're welcome to your favorite educational math channel. Good, this is my math friend. Great. In the previous videos, we looked at um, the relationship between factors and multiples and that of prime and composite numbers. This lesson, you're going to look at the divisibility test. Very well. Okay, what you've been waiting for. Great, it's going to be exciting. How to test whether a number is a factor of another or is a multiple of another. Great. Before we move on, I want you to like, watch, subscribe, and then hit the notification bell and then share. It's very, very important. Okay, great. Let's move on. So remember, we established the fact that factors factors are just numbers, okay, that divide other numbers which are bigger. Good, leaving no remainder. The opposites as multiples. Multiples are also numbers that can be divided by or they are divisible by other numbers which are smaller or lesser. Great. We also established that when you have two numbers, let's say 2 times 3, giving you 6, the 2 and the 3 are the factors, and the answer, your product, becomes your multiple. Great. Let's move on. Having freshed our mind on that, you see, if you'll be able to really identify, okay, whether a particular number is a multiple of another or it's a factor of another, there are certain test rules. There are certain test rules. That's what we call the divisibility tests. Okay, as you see on the board. Great. Let's move on. Let's start with the test rule for 2. We want to find out if a number is a multiple of 2 or if 2 is a factor of that number. Very well. What is the rule? The rule says that the last digit it's either 0, 2, 4, 6, or 8, as you see. Very well. So let's look at an example. Great. An example is 75. And then we have um 800 and 8,000. Okay, let's use 8,026. Very good. What is the last digit in the first number? 75. The last digit is 5. Starting from the right, moving this way. And then last digit over here is 6. Okay, so let's compare. As 5, does 5 fall in this range? Is 5, 0, 2, 4, 6, or 8? Do you see it here? No. So then because the last digit is not a 0, 2, 4, 6, or 8, then we say that this number 75 is not a multiple of 5 or is not divisible by 5. Divisible by 2, sorry. 75 is not divisible by 2 or it's not a multiple of 2. The other way around, you can say that 2 is not a factor of 75. Great. Look at the second example, 8,026. 8,026. Good. What is the last digit? 6. Look at 6. Do you see 6 over here? So it should be 0, 2, 4, 6, or 8 before we can say that divisible by 2. Yes, it's over here, it's in this range. So because 6 has found the last digit is 6, then we can conclude and say that 8,026 is a multiple of 2 or is divisible by 2 or 2 is a factor of 8,026. Very well. So you see the relation between factors and multiples. Good. Let's go to that of the test rule for 3. Great. What is the test rule? It says that the sum of the digits is divisible by 3. That it should be divisible by 3. Okay. Sum means we are adding. Let's look at this example. 9,415. Okay. Let's sum the digits up. Okay. So 9 plus 4 is what? 13 plus 1. So we have 9 plus 4 plus 1 plus 5. 9 plus 4 is 13 plus 1, 14. Then plus 5 is what? 19. So we have 19. So then it's 19 divisible by 3. When you sum it up, 19. How many groups of 3 go into 19? With leaving no remainder. Take note of that. When there's a remainder, it's not. So do we have, okay, so we have 3 times 6 gives us 18. 3 times 7 gives us 21. So 3 can't go into 19 exactly without a remainder. So then because of that, we can conclude and say that this number 1, 2, 3 comma 9,415 is not divisible by 3. You get that one very well. Let's look at an example from the same out of the 3. Good. So, what about this one? 6, 6, 1, 5. So 615. Very well. So let's sum the digits up. 6 plus 1 plus 5. 6 plus 1 is 7 plus 5 is 12. Very well. So we have 12 over there. Now in 12, 12 is it divisible by 3? How many groups of 3 go into 12? That's 4, exactly, without a remainder. So then we say that 615 is a multiple of 3, or is divisible by 3, or you see that 3 is a factor of 615. Very well. Let's move on to the test rule for 4. Test rule says that the last 2 digits should be divisible by 4. The last 2 digits should be divisible by 4. Good. So let's use the same number, 615. What's the last 2 digits? It's 15. Yeah, we are not sum. They didn't say sum. Just pick the last 2 digits. 15. That's 15 divisible by 4. Means that leaving no remainder. Okay, so we have how many groups of 4 can go into 15? We have only 3 groups. 4 times 3 is 12. And leaving a remainder of 3. Very well. So since there's a remainder, then we can conclude and say that 615 is not a multiple of 4, or it's not divisible by 4, or 4 is not a factor of 615. Okay, great. So which case permits that? So if you have um, okay, so 728. What's the last digit? Last 2 digits. 28. It's 28 divisible by 4. You know, remember, 4 goes into 28 7 times without a remainder. So we can conclude and say that 728 is divisible by 4. You got that one? Very well. Let's go to the test rule for 5. For 5. It says that the last digit should be either 0 or 5. Good. So if I have 22,008, what's the last digit? It's 8. Is 8 0 or 5? No. Good. Let's say I change the last digit and make it so it doesn't matter the number of digits in that number. Your focus is on the last digit. That is for the test rule for 5. Last digit is 0. Is 0 here? Yes. So this number is divisible by 5. Let's say the last digit is 5. You can even have this 1 1 in 10 any digits. On the last digit is 0 or 5. Divisible by 5. Great. Let's go to the test rule for 6. Okay, your extreme right, we have as the rule says that the number should be divisible by both 2 and 3. Great. So let's look at an example. Very well. So 2,874. Very well. It should be divisible by both 2 and 3. So let's test whether it's divisible by 2, then move to that of 3. The rule for 2 says that the last digit should be either 0, 2, 4, 6, or 8. And we have 4 here. So it's a multiple of so yes, it is a multiple of 2. Very good. Because of the 4. Now what about the 3? What's the root for the 3? It's the sum of the digits. So let's sum the digits. 2 plus 8 plus 7 plus 4. 2 plus 8 is what? 10 plus 7, 17 plus 4 is what? 21. Good. So we say it's 21 divisible by 3. How many groups of 3 go in 21? 7. Leaving a remainder. Good. So then, because it is this number is divisible by 2, where the last digit is 4, and also divisible by 3. That is when we sum the digits divided by 3, give us number exactly without a remainder, then we can conclude and say that 2,874 is divisible by 6, or is a multiple of 6, or we say 6 is a factor of 2,874. Very well, good. So it should be able to um, work for both 2 and 3. Good. Let's go to that of 7, the test rule for 7. What does it say? The extreme right, it said if subtracting double of last digits from remaining digits is divisible by 7. Very well. Let's look at an example. You understand the test rule very well. Okay, the example says that 8, 8, 9, 2, 8,892. Okay, now it said subtracting double of last digit. What's the last digit? Last digit is 2. So double of 2 is what? What's the double of 2? It's 4. Okay, good. Now let's take the 4 from the remaining digit, which is 889. So take 4 from 889. What do you have? 9 minus 4 gives us 5. So 885. Good. So it said if after you subtract double of the last two digits, which is 4, from the remaining digits, and then the answer is divisible by 7. So then the answer we got was 885. 885, is it divisible by 7? Is 885 divisible by 7? Let's find out. 885. We can use a lot of methods. Okay, we learned about the box method in previous one of the lessons. Okay, learned about the box method. Okay, great. So let's find out. Can 7 go into 8? Yes. How many times? How many times? 1 goes here, 1. So 7, 1, 7. Follow the rules. Now 1. Can 7 go into 1? No, it's small. So you move it and add it to the 8 over here. So you have 18. Great. This way. So 7 times what give you 18? It's not possible. So how many groups can go into it? You have only two groups. 7 to 14. Number 4. Can 7 go into 4? No, because 4 is smaller than. Remember, I said the number here should always be bigger than this one, but this is small. So if it's small, well, this is the box method. If it's small, you move it and add it to the 5 over here, and 45, which is now bigger than the 7. So then you move on. Can 7 go into 45? How many groups? Okay, 6 groups. 7 times 6 gives you 42. Okay, so you realize that 5 minus 2 is 3. You have minus 3. There's no other digit over there to add it. So you can stop here and see that 126 divided a remainder 3. Now, because there is a remainder, we say that 800 and what? Oh, sorry. Okay, yeah. So we say that 885. Okay, 885 is not divisible by 7. Do you get that? Because that was a remainder. So the first number we were using, 8,000, 8,000. It was 8,000, 890, 92. That was the number. You see that? So we say that because there's a remainder, that's not divisible by this. So that is the test rule. Okay, for 7. Great. Let's look at the test rule for 8. We say that the last 3 digits should be divisible by 8. Okay, very well. Let's look at an example. Okay, so we have an example like 2,400 and 9. Okay, let's sum. What are the last three digits? Sorry, for the rule for 8. Last three digits are 409. It's 409. Is it divisible by 8? Huh. You see that the beauty of it is that they give you a larger number, and then the rules helps the numbers to reduce, so that you can be able to divide easily. Good. So from 2,409, we have only 409. Is it divisible by 8? Let's find out. 409 is it divisible by 8? Can 8 go into 4? No, you add the 40. 8 goes into 40 how many times? Okay, goes here 5 times. Good. Then you have 9. Can 8 go into 9? Goes into it 9, only 1. So there'll be a remainder of 1. So 8 can go into 409 exactly because there's a remainder. Because there's a remainder, and we see that the entire number 2409 is not divisible by 8, or is not a multiple of 8, or 8 is not a factor of 2409. Trust you got that very well. Okay, let's look at the test rule for 9. The test rule for 9. Test rule for 9. Okay, the test rule says that the sum of the digits should be divisible by 9. The sum of the digits should be divisible by 9. Sum of the digits. Okay, so let's find out. Let's look at an example. Okay, an example where sum of the digits is divisible by 9. Okay, so can we use the same example? Okay, so you have 8, you have 9 here. Um, okay, so 891. Very well. Let's sum the digits up. 8 plus 9 plus 1 plus 8 plus 9, 17, plus 1 is 18. Let's find out, is 18 divisible by 9? How many groups of 9 go into 18? We have 2, exactly, without a remainder. So because after summing the digits up, 9 goes into the sum exactly, then we can conclude that 891 is divisible by 9, or is a multiple of 9. Or the other way around, we say that 9 is a factor of 891. Great. Okay. The last test rule, that of 10. How do you test whether a number is divisible by 10? Okay, so the test rule says that the last digits should be 0, just 0. Okay, so pick any number you see anywhere, or just pick any number, and then find out if the last digit is 0. So an example is, okay, so which number is this? 1, 2, 3, comma. Okay, 3,119,208. That's what we have over there. So 3,119,208. Very well. Okay, what's the last digit? So you see how huge the number is. Let's just check the last digit. Last digit is 8. Is 80? No. So because last digit is not 0, we say that 3,119,208 is not a multiple of 10, or it's not divisible by 10, or is 10 is not a factor of that number. Okay, let's say the last digit. Let's say the last digit is 8. Sorry, a 0. Okay, so that then it fits into the rule. So that number, so we see the entire number is divisible by 10. Okay, so it could be 0 or 2. What about 2? No. The only rule is that the last digit should be 0. Very well. I trust that you really understand everything. So these are the simple rules. You just have to go through them and then just practice often. Very well. Okay, great. In our next lesson, we are going to look at finding the highest common factor, or what you can also call the greatest common factor, and the least common factor, least common multiple. Note that there are a lot of methods. Okay, so we'll be looking at some simple methods to use to find the highest common factor and the least common multiple. Very well. Okay, I trust that you enjoyed that video and you found it very interesting. Very well. So then, if you want more of it and you want to take part in the next lesson, all right, so do this for me. Remember, like, watch, subscribe to the channel, hit the notification button and the bell, and then you share. Share to your groups, share to your families and friends, share it all over the world. Okay, stay blessed, my math friend. Bye.